So, continuing with our discussion on vector algebra, we have the scalar product in which we multiply two vectors together and the answer is a scalar quantity. Okay, scalar product. The scalar product is also known as the dot product because when you look at the equation for the scalar product, we use a dot to represent the multiplication. So, scalar product, dot product, they are one and the same. In scalar product, as mentioned, two vectors are multiplied together and the result is a scalar quantity. The scalar quantity C is equal to vector A dotted with vector B. Let vector A be this vector and vector B be this vector. If you connect their tails together, you'll be able to get the angle, the angle between the two vectors. Okay, the angle of orientation between the two vectors, between the orientations of the two vectors. Angle theta. Scalar product is equal to A dotted with B is just equal to magnitude of vector A times magnitude of vector B times cosine of the angle between A and B. Okay? The scalar product may be positive or negative, but note that magnitude is always positive. So magnitude of A is positive, magnitude of B is positive, so positive times positive. Whether C, the scalar product C will be positive or negative will depend upon cosine theta. Will depend upon the value of the angle between A and B. So for example, consider the following situation. You have two vectors, vector A, 5 meters, 30 degrees below negative x. Vector B, 3 meters per second squared, 10 degrees to the right of positive y. Even though they have different units, you'll be able to multiply the two vectors. Draw the two vectors. Vector A, 30 degrees below negative x. Vector B, 10 degrees to the right of positive y. Draw them tail to tail or connect the tails of the two vectors together and you'll be able to determine the angle between the orientations of the two vectors. The angle between A and B. 30 plus 90 plus 10 degrees will give you 130 degrees. The scalar product between A and B, C is equal to A dotted with B, is just equal to magnitude of A, 5 meters, times magnitude of B, 3 meters per second squared, times cosine of the angle between A and B, 130 degrees, and that will give you C is equal to negative 9.6418.14145 meters squared per second squared. The units will also multiply. Meter times meters per second squared will give you meter squared per second squared. In this example, the scalar product is negative. Positive times cosine 130 will give you a negative answer. So, the negative sign will depend upon cosine theta. Reversing the order of the multiplication does not matter. It doesn't matter if B dotted with A or A dotted with B, as long as you have the same vectors A and B, that will give you the same answer. So if D is equal to B dotted with A and C is equal to A dotted with B, that means scalar quantity D is just equal to scalar quantity C. The order in which you multiply the vectors using scalar product does not matter. The scalar product can also be done with vectors that are in unit vector notation. So say you have vector A is equal to axi hat plus ayj hat plus azk hat, and B is equal to bxi hat plus byj hat plus bzk hat, and you get the dot product between them, A dotted with B. Just multiply the x components together, ax, bx. Multiply the y components together, ay, by. Multiply the z components together, az, bz. And then add them all up, you get the scalar product C. And that's it for now. In the next video, we'll move on to the third type of vector multiplication, the vector product. So thank you for watching.